Well, hello, and welcome to the first in what I hope will become a series of videos that will document the creation of the electrical system for my R2 unit. This video has been a long time coming. I've been putting off doing the electrical system on the droid because, well, frankly, I don't really know all of what I'm going to do. I don't have a detailed plan. I've got lots of parts here, and earlier I thought about, well, I'll tell you about what all the different parts are and the things that I've gotten, but that's information overload, and I think that's a big reason why it's taken me so long to get started on this. Every time I would look at other people's electrical systems, I just got overwhelmed with questions. And what I realized that is finally going to work best for me is I just need to let this system evolve on its own. So rather than give you a start to finish overview of everything that I hope to do, I'm just going to focus each video on the next thing that logically comes to mind, and then we'll see where things go. I have moved R2 off to his little corner, and I've cleared as much workbench space as I can so that I can start working on building this system out. So without getting too much into the weeds, let's go ahead and start with the first thing that I need to do, which is really just connect the batteries and provide a 24 volt and a 12 volt bus that's going to serve as the backbone for the droid. So let's start working on that. So one of the first things that you need to do when designing your power system is you need to at least have a good understanding of what your droid's power needs are going to be. In terms of amp draw is really kind of the main thing. Now I've mentioned before that I'm going to be running 24 volts for my drive motors, my dome motor, and my amplifier. And then everything else in the droid, the Arduino runs at 12 volts. And then most of the servos and microcontrollers are going to run at 6 or 5 volts. So really what you need to do when you start this system, what I've learned is you need to understand the total amp draw of all of your components. So for instance, I have 150 watt drive motors at 24 volts. That works out to 6.25 amps max draw for each one of those drives. So combined, that's 12.5 amps. My dome motor lists a stall pull of about 3 amps. And then figure a 100 watt amplifier at 24 volts will probably be about another 4 amps. So on the 24 volt side, I'm looking at, probably less than 20 amps total pull. And then on the 12 amp or the 12 volt side, you've got the Arduino and you have servos and sounds and lights. Those collectively, they might pull 10 amps. I'm not sure. I haven't done all the math. But based on that, I'm going with a 40 amp main power switch. This is a switch and fuse in one. So I think I'm reasonably safe there that putting that switch on the root of my system is going to be sufficient for the total amp draw that I have. So just as that main switch needs to support the amp draw for everything in the droid, I also need to be able to convert the 24 volts down to 12 volts and have that be done in such a way that it can support the entire amp draw of everything 12 volts and below. So I mentioned before, it's probably going to be in the neighborhood of maybe 10 to 15 amps max. So this is a 24 volt to 12 volt voltage converter that can actually support up to 30 amps. So this is more than sufficient to what I'm going to need, just understanding that everything downstream of the battery that runs outside of the 24 volt realm is going to pass through this. So I couldn't use, for instance, some of these smaller lightweight voltage converters because most of these will only support maybe 5 amps, 9 amps, or 10 amps if you're lucky. So I did need to get something that was a little beefier to put close to the battery. So then the third thing that you need to think about when you're designing the early stages of your electrical system is wire gauge. Wire gauge is mostly driven by the amperage that you expect to pass through that wire. The higher the amperage, the thicker the wire that you're going to need. It is worth mentioning that you know, the amperage is inversely proportional to the voltage. So at higher voltage, you're going to be passing fewer amps. A 12-volt system is going to have twice the amps as a 24-volt system. So in my case, I can probably get away with a higher gauge or a thinner, if you will, wire. That being said, though, I'm still going to err on the side of caution, and I'm going with 10 gauge stranded wire at the battery. This should be more than sufficient to support the amp draw that I'm going to have. It is also worth mentioning that if your situation calls for wire that is thicker than 10 gauge, if you need to go to 8 gauge, most of the connector kits that I've found, kind of like those back there, a lot of them come color coded with the highest gauge being 10 or 12 gauge. So any of the connectors that you might shop for, if you do need to go with 8 gauge wire, you're probably going to need to get some separate connectors from a different source. So yeah, so that's it for wire gauge. So I'm going with 10. And then finally, the ultimate goal of this first step is to connect the batteries in series, provide 24 volts to this smaller fuse block. Actually, the only thing that's going to be fused on the 24 volt side is going to be the amplifier. Both the Sabertooth and the Siren motor controllers for the drives and the dome motors, respectively. Those should not be fused. They should be running off of the direct, unregulated power from the battery. And then I have this other fuse block. It's slightly larger. This will be my 12 volt fuse block. So the goal here is to get the batteries hooked up and have a consistent 24 volt and 12 volt bus for my system. All right, so after a little bit of time playing around with wires and connectors, this is where we've wound up. So if we start here at the battery, we have the two batteries now connected in series. You have one of the positive terminals connected to the negative terminal of the second battery. You have the negative lead going directly to the bus bar, and you have the positive lead, in this case, routing through my breaker switch. I added a disconnect here so that I could have one switch permanently mounted in the droid and a second switch that I can use on my bench power supply. So if I need to work on things in the future, I can take the batteries out and my electronics board out, and I can just wire in the new switch. From here, I have the 24 volts going to the 24 volt fuse block. And then I also have the 24 volts feeding into the DC 12 volt power converter, and then that feeds into this 12 volt fuse block here. So now with the switch on, if I check the voltages to the 24 volt fuse block, I get my, well, right now it's 26 volts. The batteries are fully charged. And on the 12 volt connection, you'll see I'm getting my 12.1 volts. So with that, we've now got the batteries hooked up to give me 24 volts and 12 volts. And that's pretty much what I wanted to accomplish here. So I know that really isn't a whole lot, but I think my goal with these videos is to try and make more frequent updates, but try and focus on one specific component of the electronics design. Again, I was just kind of feeling overwhelmed when I was looking at completed wiring diagrams and realized that they told me the how, but they didn't really explain the why. And so I think my goal with this is to just kind of walk you through the process as I go through it, as I try and understand the why some of these decisions are being made. And it's very likely that some of the decisions I've made today might even end up changing at some point down the road. I might learn of things that I could have done differently that I will probably change before moving all of this stuff into the droid. But anyway, I wanted to kind of keep this focused on one specific task, and then hopefully in the next week or so, I will be able to post some additional updates. So I think that's going to cover it for this. Take it easy.